You know how this is gonna end, right? Like you and your guinea pig and the bacteria living in your bathtub and the Real Housewives franchise, all those things are gonna end. And of course you know that. But also big, permanent seeming things are gonna end, like the Earth and the Sun and this galaxy and that galaxy over there and the universe. The end's not gonna happen anytime soon, but give it some time and even the universe will change into something different, something we wouldn't even recognize, and then gone. How exactly that's going to happen is, of course, up for some serious debate, because what we don't know about the universe could feel like a universe. But astrophysicists, cosmologists, and particle physicists are pretty smart people, and they think about this all the time. So at this point, what do they think is going to happen to Earth and to the solar system and the universe in the far distant future? It's good stuff to know, just in case you happen to run out of other stuff to worry about. The universe is about 13.7 billion years old, give or take about 130 million years, but it hasn't always been the way it is now. It's believed that it was born with the Big Bang as an unfathomably hot, dense point called a singularity. The Big Bang didn't occur as an explosion, like you would think, even though it's called the Big Bang. And the universe didn't expand into space because space didn't exist before the universe was formed. Instead, think of the Big Bang as the simultaneous appearance of space everywhere in the universe. If you could picture that. I, for one, cannot. But the people who study this stuff say that the universe hasn't expanded from any one spot since the Big Bang, but that space itself has been stretching and carrying matter with it. So, the universe started at a single hot, dense point smaller than an electron or something, and at the ripe old age of 1/100th of a billionth of a trillionth of a trillionth of a second, this point began to expand faster than the speed of light in a process called inflation. It's thought that in the same instant the universe doubled in size at least 90 times, growing from the size of a subatomic particle to the size of a golf ball. Ta-da! Whole universe! From there, it continued to grow a little more slowly, and as it expanded, it cooled, and matter began to form. For instance, just 1 second after the Big Bang, the fundamental building blocks of matter, called quarks, start to assemble into subatomic particles like protons and neutrons. And for the next 380,000 years or so, as the universe continued to cool and become less dense, these particles began to structure themselves in a way that we would recognize. They started colliding to form atoms, protons and neutrons inside a nucleus tied up together with a tiny little orbit of electrons. Here, some of the first lightest elements like helium, lithium, and of course hydrogen began to appear. At this point, the universe transformed from a dense fog of particles into something transparent. But it also went completely black, since no stars had yet formed. So the period between 380,000 years to about 400 million years after the Big Bang is what we call the cosmic dark ages, since there weren't any big objects emitting visible light yet. But for the next 500 million years after that, clumps of gas began to collapse enough to form the first stars and galaxies. The expansion of the universe gradually slowed as gravity tried to pull matter back in on itself, but then, about 3.5 billion years after the Big Bang, something weird started to happen. A force stronger than gravity began to overpower this pull and accelerate the expansion of the universe. This force, called dark energy, is a leading candidate for the title of least understood thing in physics. All we really know is that it's a repulsive force that causes the universe to expand at an ever-increasing rate. So at this point, you probably get why the fate of the universe is so tough to predict. Our information is profoundly incomplete. We keep finding out about stuff like dark energy, and we're like, oh, okay. That's gonna take a minute to process. Anyway, a little south of 9 billion years after the Big Bang, our solar system was born, and then our little adorable planet showed up, and here we are. But what's gonna happen to us? Because everything ends. I mean, the second law of thermodynamics tells us that as time passes, entropy, that is, disorder in general, increases on all levels. Stars, including our sun, exhaust their supplies of fuel. Planets come untethered from their stars, and galaxies break apart. We're not 100% sure about anything regarding the true nature of the universe, so the end could happen in a different way. In fact, a lot of really smart people think it will happen differently. But one thing pretty much everybody agrees on: there's almost certainly going to be an end. But here on Earth, we've got some things besides cold black nothing to worry about. Even if the end of everything does happen, you won't be around for it. Neither will I, and neither will our great-great-great-great-great-great-great-great-great-grandkids. They'll be past caring one way or another. Because on Earth, things are always changing. It's what makes life possible. but it can also be kind of unconducive to immortality, if you know what I mean. In the next 100,000 years, Niagara Falls will erode away into Lake Erie, the moon will slow down the rotation of the Earth enough that we'll have to add a leap second to our clocks every day, and if global warming doesn't tamper with it, we're due for another ice age. Oh, and the movement of the stars will render most of the constellations we see from Earth unrecognizable, which will make astrologers, presumably, really confused. In the next 1 million years, our planet is due for a good old-fashioned catastrophic extinction event. These have happened periodically over the past 4 billion years of Earth's history. It could be the eruption of a supervolcano, which have been frequent enough to change the game in terms of the history of life on Earth. Think of an explosion so major that sulfuric acid mixed with volcanic ash blocks the sun all over the world for like 10 years and sends the planet into a volcanic winter. It's happened before, lots of times. We've even survived one before, although barely. Some scientists think that the eruption of the Toba supervolcano in Indonesia 70,000 years ago left only about 1,000 breeding pairs of Homo sapiens to repopulate the Earth. And did they ever? Now, sometime in the next 100 million years, we're likely to be hit by a meteorite similar to the one that possibly killed off the dinosaurs, because things in space are not so far apart that they don't run into each other occasionally, and big space rocks have collided with the Earth for as long as there has been an Earth. In fact, that's probably what caused most of the major extinction events on Earth so far. Of course, some people think that we could destroy one of those space rocks before it punches us in the face, but who knows where humans will be, if anywhere, 100 million years from now. 250 million years from when you watch this, we will make a full circuit around the Milky Way, in which time all the continents on Earth may have fused into a single supercontinent. And now we gotta start thinking about the sun getting bigger, because that's what's gonna happen next. In 600 million years, the sun will begin to enter the red giant phase, basically a star's midlife crisis. A red giant has fused all its hydrogen into helium, causing it to heat up and expand to more than 100 times its original size. It'll take a few billion years for the sun to actually swallow the Earth, but its growing luminosity will probably cause enough climatic changes on Earth, like all the oceans evaporating, for instance, that in 1.3 billion years, all plants and animals will have gone extinct. And the only living things will be bacteria and archaea hanging out in little pockets of liquid water at the Earth's poles. In 1.6 billion years, even those extremophiles will be having a tough time of it. In about 3.5 billion years, the surface of the Earth will resemble that of Venus, and the Earth's orbit will widen with the growing, yet less massive sun until about 7.9 billion years from now, when the sun will swallow up Mercury, Venus, and Earth. Some researchers have suggested that if humankind has figured out how to survive that long, maybe we could lasso a passing asteroid and get a tow into wider orbit, or we could move on to one of Saturn's moons, like Titan, because at that point it might be a perfect place for us. 7.9 billion years though, we are so not going to be around, but I love the optimism. Anyway, 8 billion years from now, the sun will become a white dwarf, which by that point will be about half its present mass, and by 14.4 billion years from now, it will be cool enough to be invisible to human eyes. It's been a good sun though. You better appreciate while it's still keeping you warm. After that, our solar system is pretty much dead. Now, it's kind of hard to say what will happen to the universe. Every astrophysicist's got ideas, of course, and each idea has a kind of painful nickname. The Big Rip, the Big Crunch, the Big Freeze. Which scenario will win out mostly depends on dark energy, which we don't know diddly about, if you remember. Let's start with the Big Rip. Here, the rate of expansion driven by dark energy keeps growing and growing without limit, becoming so extreme that it actually overwhelms all of the fundamental forces of physics, from the gravitation between objects to the strong and weak forces that hold subatomic particles together. In which case, not only will galaxy clusters break apart and star systems dissipate, but every form of matter, right down to molecules and atoms, will be shredded into oblivion. Some physicists say that this could happen as soon as 17 billion years from now. Or another possibility is that, like 100 billion years from now, the strength of dark energy will diminish as time goes on, and the expansion of the universe will stop accelerating. In this case, if dark energy weakens, gravity might ultimately win the tug of war and pull all the matter in the universe back on itself. That result is referred to as the Big Crunch. But these days, a lot of bets are being placed on the Big Freeze. In this scenario, dark energy keeps the universe flying apart until everything gets so far flung that there's simply no thermodynamic energy left. There'll be no motion, no heat, no life, stars will burn out, new stars will stop forming, and the cosmos will dissipate into cold, dark nothingness. This party isn't expected to start for about 100 trillion years, though, so that's good news. But these aren't the only ideas, they're just the most popular ones. Some cosmologists think that as entropy in the universe increases, it will configure itself into something so complicated it will become a self-aware entity. So yeah, I'm with the guy who thinks the universe could become a giant brain. That sounds cool. But that's what's great about this stuff. Cosmologists are constantly bickering over questions like, is the universe even real? Are we real? How many universes are there? Is the universe going to recur over and over again in an endless cycle of big bangs? Why can't you unscramble an egg? Because when you're trying to figure out the nature of the universe from a tiny rock in deep space, there are no stupid questions. If you have any comments or questions or ideas, you can get in touch with us on Facebook or Twitter, or of course down in the comments below, and we will endeavor to be a part of this discussion, which is bound to be a somewhat complicated one. And if you want to keep getting smarter with us here at SciShow, you can go to youtube.com/SciShow and subscribe.